excitation energy and ionization energy. So excitation energy is the energy required by an electron in an orbit to jump to a higher orbit. So if the electron transits from a lower to a higher energy level, it will have the excitation energy. Meanwhile, for the ionization energy, it is the energy required by an electron in the lower energy level to be completely free from the atom. So, dia sama juga macam excitation, dia bergerak ataupun transit from lower energy level to higher energy level, but the final energy level will always be infinity. Bermaksud, elektron tu dah keluar terus daripada atom tersebut dan menjadikan atom tu sebagai ion. So, the energy we call as ionization energy. Excitation energy dan ionization energy, kedua-duanya akan absorb energy. Cuma kita nak bezakan. Kalau dia just naik daripada satu level ke satu level yang lain, dia adalah excitation energy. Tapi kalau dia keluar terus dari atom, kita panggil sebagai ionization energy. Example 8.3, the lowest energy state for hydrogen atom is E1 equal to negative 13.6 electron volt. Calculate the frequency of the photon required to ionize the atom. So when the electrons make a transition, it will absorb or release energy. So the energy absorbed and released is in terms of photon. So kalau dia kata to ionize the atom, we know that final energy will be infinity. First, we can find the change of energy during the transition. We will get 13.6 electron volt. It is positive because the electron absorbed the energy. And then to find the frequency, use this equation. Delta E equal to HF. Substitute Planck constant into this equation. Don't forget to convert delta E in electron volt to joule. Then you will get frequency 3.28 times 10 to the power of 15 Hertz. Example 8.4, a blue spectral line is one of the visible spectral lines in the line spectrum for hydrogen atom. Its wavelength is 4.34 times 10 to the power of negative 7 meter. If the photon emitted ataupun energy yang di-release is due to the transition of electron to the energy level negative 3.4 electron volt, determine the initial energy state. So this is the energy final. What will be the energy initial? From the equation, it told us that the photon is emitted. Bermaksud energy is released. We also have the wavelength. So equation wavelength we can apply into this equation. F equal to C over lambda. Delta E equal to HF. Delta E is equal to E final minus E initial. So if we want to find the E initial, we need to have the delta E. Nak dapatkan delta E daripada mana? Daripada equation ini. Tapi kita kena cari dulu frequency. How to get the frequency? By substituting the speed of light and also wavelength given in the equation. Frequency equal to speed of light 3 times 10 to the power of 8 divide with the wavelength 4.34 times 10 to the power of negative 7. The frequency will be 6.91 Hertz. Substitute frequency into the equation of delta E. Planck constant is 6.63 times 10 to the power of negative 34 times with the frequency 6.91. So the change of energy will be 4.58 times 10 to the power of negative 19 joule. Okay, and since the photon is emitted or the energy is released, we put the negative sign here. This value will be in joule, so to convert it into electron volt, divide it with 1.6 times 10 to the power of negative 19. We will get negative 2.86 electron volt. So substitute into the equation, delta E equal to E final minus E initial. Delta E is negative 2.86. E final is negative 3.4 minus with E initial. Here you will get the initial energy is equal to negative 0.54 electron volt. During the transition of electrons, another equation that we can use to find the wavelength of energy emitted or the photon, we can use this equation 1 over lambda equal to Rydberg constant times with 1 over the energy level final square minus with 1 over the energy level initial square. So this equation can only be used when electron makes a transition from higher energy state to lower energy state, where during the transition, photon or energy are emitted. When the energy or photon emitted, we have this line spectrum of hydrogen atom. If the electron transit from any higher level to ground state or n equal to 1, we call it as Lyman series. When the electron makes a transition from any energy level to n equal to 2 or the first excited state, we call it as Balmer series. And there are also Paschen series, bracket series, and also Fun series. Instead of having their own name for each series or each transition, they also produce light during the transition. Bila energy is released or the photon is emitted, they will also produce some lights. For example, we have ultraviolet light for Lyman series, visible light for Balmer series, and also infrared for Paschen series. Untuk dapatkan ultraviolet light is the transition from any higher level to n equal to 1. So spectrum lines with the longest wavelength produced by nearest transition. Kalau electron move from a higher level to the nearest energy level, contohnya daripada 3 nak pergi kepada 2, dia akan menghasilkan longest wavelength. But if the transition is far, contohnya daripada infinity to n equal to 1, it will produce shortest wavelength. For example, 8.5, the electron in the hydrogen atom makes a transition from the third excited state. So this is not n equal to 3, but it's actually n equal to 4. Okay, sebab n equal to 1 is not excited state, dia adalah ground state. So third excited state is equal to n equal to 4 to the ground state. This one is n equal to 1. Calculate the wavelength of the emitted photon. Okay, kalau dia kata emitted photon bermaksud energy is released or photon is released. So we can use this equation, substitute the Rydberg constant and also the energy level. Then you will get the wavelength is equal to 9.72 times 10 to the power of negative 8 meter. For question B, what is the frequency of the emitted photon in A? So when we have wavelength, we can use this equation, F equal to C over lambda. We will get 3.09 times 10 to the power of 15 Hertz. And for question C, state the spectrum produced. We are going to look at the final energy level, which is ground state. So kat sini kita dapat tahu yang mana dia akan menghasilkan Lyman series. Example 8.6, a hydrogen atom in an excited state transit from n equal to 1 to n equal to 4. So this is energy initial and this is the energy final. Calculate the energy state in E1 and also E4, energy level 4. So for this one, we can use the equation En equal to negative E1 over n square for both energy level. So energy level at n equal to 1, we will get negative 13.6 electron volt. You can also use negative 13.59 electron volt. And then energy level at 4 is equal to negative 0.85 electron volt. Question B, determine the energy that must be absorbed by the atom. This refers to the change of energy. So energy final minus energy initial, substitute the values, then you will get 12.75 electron volt. The answer is positive because energy is absorbed by the atom. Question C. Determine and show the energy level diagram. The possible energy of the photon will be radiated if the electron transit to the lower state. Okay, let's say sekarang ni, electron tadi, dia dah naik daripada n equal to 1 to n equal to 4. Now, the electron currently at n equal to 4. Let's say it is here. And it is not stable, dia berada dekat kawasan excited state. Bila electron tak stable, or at the excited state, it has the tendency to make a transition to lower energy level. So what are the possibility? First, there is the possibility to transit from n equal to 4 to n equal to 3. The possible energy of the photon will be radiated during this transition is E final minus E initial. E final is E3, E initial is E4. Substitute the energy, then you will get negative 0.6 electron volt. This is the energy released or photon emitted ataupun photon radiated during the transition. The second possibility is electron at n equal to 4 has the tendency to move to n equal to 2. Ini second possibility. So what is the energy during the transition? Final energy will be n equal to 2. Initial energy is n equal to 4. Here you will get the negative 2.55 electron volt. Negative because the energy is released during this transition. And how do we get the value of energy at each level? Use the equation En equal to negative E1 over n square. So nanti you bolehlah label, lukis the diagram, energy level diagram. And then label energy at each level. And label dia punya the number of energy level like this. Okay, so you kena sketch lah to show the energy level diagram. Next, the electron at n equal to 4 also has the possibility to make a transition from n equal to 4 to n equal to 1. What will be the energy during this transition? Energy final will be E1, energy initial will be E4. So the energy release ataupun photon radiated is equal to negative 12.75 electron volt. So based on this energy level diagram, we have three possibilities and there are three energy for each transition. Example 8.7, calculate the longest and shortest wavelength for a Balmer series. Kalau Balmer series, it is the transition from any high level to n equal to 2. So for the longest wavelength bermaksud transition tu berlaku dalam jarak yang dekat. The electron will make a transition from n equal to 3 to n equal to 2. Substitute into this equation, then you will get 6.56 times 10 to the power of negative 7 meter. For the shortest wavelength of the energy released by the transition, we are going to use the farthest transition, which is from infinity to n equal to 2. Substitute into the equation. Final is n equal to 2 and initial is infinity. You will get 3.65 times 10 to the power of negative 7 meter. So you can look at the value. This is the shortest wavelength and this is the longest wavelength produced by the electron during the transition.